Hi, everyone. Welcome to our lecture about energy, which is going to kind of skim over chapters 14 and 15. So the first thing that I'm going to talk about is energy production. Generally speaking, Western countries, Western nations such as the United States, we consume a lot of energy, um, far more than we did 100 years ago. And so we need to get this energy from some energy sources. And so we have primary energy sources, and this is energy that is contained in natural resources, things like coal and oil and sunlight and wind and uranium. And then secondary energy sources, this is when we take our primary energy and is converted into another form, like electricity. So just to kind of recap that, right, we use coal to make electricity, but we could also um, if we really wanted to, just burn coal directly and get heat right off of that. But we convert it to electricity to use in our homes. There are two major forms of primary energy. Those are non-renewables, and we're going to talk first about non-renewables today after I get through some energy efficiency, and then we're going to talk about renewables. But non-renewables are those derived from sources that exist in limited quantities, fossil fuels and nuclear energy as well, which uses uranium. And then we have renewable energy, which are sources that are not depleted when used, or they can be replenished quickly. So solar, wind, and wood. Now, technically, you could say that fossil fuels could technically be renewable, but it takes millions of years to make fossil fuels, right? So here, in terms of renewable and non-renewable, we're literally talking about scale. So solar energy renews much faster than wood does. By the time you grow a tree and cut it down and burn that wood, that takes more time. And then again, that secondary energy is transformed from those primary sources in order to give us electricity. So for example, here we have coal, right? You have coal and you lose some energy along the way as you go to get to electricity. So if you have 100 units of, uh, of energy from coal, um, you're going to lose 70 units as heat, as that chemical energy is transformed into an electrical current. And then you're going to get 30 units that's going to go into our transmission lines. And then you're going to lose about 6 units due to the resistance in the transition lines. And then you're going to get 24 units. And then this is an old incandescent bulb, excuse me, which are really inefficient. Incandescent bulbs are like heaters that produce a little bit of light, which is why most of us use LED bulbs that last much longer and are much more energy efficient. But with light bulbs, we lose a huge amount as heat. And we're obviously not using our light bulbs to heat ourselves. And so, you can go from that 100 units starting with coal down to 1.2 units of visible light at the end. So there's a lot that is lost along the way. And then we want to think about, what are the end uses of that energy production? And rates of primary energy consumption vary dramatically by country. And that consumption, though, can be broken down into 4 sectors. So the first one is transportation, right? To run our cars and planes and trains. Industry, all of the energy that's used to make things. And then we have residential and commercial. So commercial, not producing something necessarily, but the electricity or the fuel that we use in our homes. And then finally, you could divide that up into electricity even further. And, this is oil that was produced by the United States. So generally speaking, the United States was kind of down curbing their oil production. It has gone up in the past several years, but our consumption has continued to grow. And so we have gotten much of this oil from other parts of the world. And we'll talk about distribution of oil a little bit later. But generally speaking, when we look at global primary energy sources, mostly it is fossil fuels, and which is a concern due to climate change, obviously. But 28% with coal, 31% with oil, and 21% with natural gas. Those modern renewables are really a very small slice of that pie, and ideally we want it to get much bigger. Fuel, wood, and charcoal is still used by a lot of people globally. And nuclear power is used more heavily in some areas than in others. We use it in the United States, and I'm going to talk about some of the controversies surrounding that when we get to it. We also want to think about the economics of energy resources. You may notice that sometimes you go to the gas pump and it's significantly cheaper, and you go the next day and it's much, much higher. But we want to talk about how much reserves we have. So proved reserves are a recoverable quantity of energy resources using current technology at current prices. These are reserves that we know are there and that we have of non-renewable energy at current prices. And then we also want to think about our reserves to production ratio, which is, proved reserves divided by a particular year's production or use. So how much are we using versus how much we are producing? How much are we depleting those reserves? So it's an estimate of how long a fuel source will last at current consumption rates. And so, how much coal we have left, how much oil we have left, how much natural gas we have left. The other thing that we want to think about is energy's efficiency, which we talk about in terms of energy return on investment, which is EROI. You can say EROI if you would like. This is useful energy provided by a resource divided by the amount of energy that is required to produce the resource. So again, when we, here is a, coal traveling by train through the United States, right? We have to get that coal. We have to mine it, first of all, which takes a certain amount of energy. And then we have a certain amount of energy in transportation. If an energy type has a score of less than 1, it means that more energy is invested than is produced, which is not ideal, right? We want to get more energy out of it than we are putting into it. And those estimates can vary pretty dramatically as to what you would consider the EROI, because sometimes those measurements include environmental costs as an input, and sometimes they don't. So depending upon how you are thinking about it, maybe the environmental damage is actually lowering because you are lowering the ability of that ecosystem to provide. So first, we're going to talk about non-renewable energy. Remember, those are those ones that we talked about where it's coal and oil and natural gas and nuclear power. So first, we're going to talk about coal. Coal was formed from plants hundreds of millions of years ago. So basically, you had plant matter that was deposited in layers of sediment called cold seams, and it was compressed over time. And that's how we get coal. So basically, we are burning this kind of ancient carbon. We have been using coal longer than any other fossil fuel. It was being used in England as far back as 5,000 years ago. Coal was something that really powered the Industrial Revolution, but it's pretty dirty burning fuel. When you extract and process coal, you remove the sediments from underground by underground and surface mining. So there is that kind of traditional mining that we think of where, somebody is going into a mine, which is very dangerous, and removing that. And then we also have something called mountaintop removal, which is what you're seeing here, where literally we dynamite off the top of mountains in order to get to that coal, which has very big environmental impacts on local waterways and pollution and communities. And basically you're left with this kind of desert moonscape afterwards. Particularly in Appalachia in the United States, they have had a lot of environmental degradation due to mountaintop removal. Globally, coal is used for about 67% of electricity generation. It's much higher in the United States. It's about 90%, although that's starting to change. And it's transformed into electricity at coal-fired power plants. Basically, we burn that coal to create steam to turn a turbine, and then we capture that energy from that spinning turbine. So here you can see a coal system. There's here's our coal supply, our coal hopper, that we're burning this coal, we're heating this water, creating this pressurized steam that is then turning this turbine. Then we're gathering that electric power it's producing. And then we have to cool that off as well. But there's steam released from that cooling tower, and then we have mechanisms in place to try to reduce that pollution that is coming out of a coal-fired powered plant. So again, there are several environmental impacts of coal. First, mining destroys habitats. So when we think about mountaintop removal, which I showed you a minute ago. And then we also have problems with mine tailings, which mine tailings are basically the debris, the rock and debris that's left over after mining operations, and they contain high concentrations of sulfide. And when these are exposed to oxygen, they are transformed into sulfuric acid, which then runs down into streams, and it can harm ecosystems and fish. And then we also have problems with exhaust from these coal-fired power plants, which can lead to numerous toxins in the air, including mercury and CO2, right, which is a greenhouse gas. So we're very concerned about in terms of climate change. Again, coal is a very dirty burning fuel. And then also this fly ash, which is this solid material waste, which can also become airborne as well. This is a picture of fly ash right here. Several years ago, and there's been less talk about it now, but during the 2008 election, a lot of people were talking about clean coal technology, investing in clean coal technology. And the idea behind clean coal technology is that you have the process by which you burn that coal, but then you capture all of that CO2 so it's not ejected into the atmosphere, and then you store it underground in a CO2 injection well. This has been done, I think there's only one facility in the United States that's now under operation doing this. This technology is not really streamlined yet. And then there are also concerns about storing that CO2 underground. So we really have a long way to go if we want to talk about using clean coal technology. Next, I'm going to talk about oil and natural gas. So in their sources and their amounts, oils are formed under very specific geologic conditions, and it's only found in a few places. A lot of kind of wealth disparities in the world, particularly in the Middle East, are due to countries that have oil and countries that don't have oil. It is formed from the remains of microorganisms, again, millions of years ago, that they became trapped beneath this impermeable rock, and they form these oil reservoirs. And they're under pressure. So when you tap a primary oil source that hasn't been mined before, that oil will actually come bubbling up out of it. But then as you extract it, it's harder and harder to get out. So we have conventional oil reserves that are in permeable rock that's fractured and porous that hold oil. Again, those easy to get to. Those are historically the most important. Then we have other unconventional sources of oil, which are harder to retrieve. And then we have also in natural gas, we have it in shale and in tar sands. Which I'll talk a little bit more about in a second, but shale and tar sands mining is really pretty environmentally devastating. So the existing reserves of oil and natural gas, half of all known oil reserves is in the Middle East. Uh, Politically, people are worried about being dependent on oil in the Middle East. People are concerned about when you have conflict in the Middle East, who gets control of that oil. 18% of it is in Venezuela, and Venezuela's part of Venezuela's current economic problems, which they have been having a lot of, are the fact that their economy was just totally based on oil, and the price of oil dropped, and their economy subsequently dropped as well. Then we have 10% in Canadian tar sands, which again is much more hard to extract. And then 2% in the United States. So we have oil, but we have a relatively small amount comparatively of global oil reserves, but we certainly use a lot of it. So when we look at those proved natural gas reserves as opposed to oil, again, a huge portion of it being in the Middle East. And this categorizes Russia as part of Europe, I believe, because Russia also has an incredible amount of natural gas. 90% of Europe and Eurasia's natural gas reserves is found in two countries, Russia and Turkmenistan. So Europe is really relies pretty heavily on natural gas from Russia. And so how do we extract oil and how do we process it? So crude oil is pumped from reservoirs that is then sent to refineries. So we can see these pumps, you can see them offshore if you drive up the coast of California. We have them out in the ocean. If you drive through the Central Valley, you'll eventually see some around Bakersfield, especially. And so that is the primary oil recovery. So the first 20% that they get out is that original flow. And then you have secondary oil recovery, which you need additional methods to get it out because it's not under pressure anymore. So you have to inject other things in there to build up that pressure. And then tertiary as well. So every time you go down a step, you use more energy to get that oil out. And then we have hydraulic fracturing, which is a process by where we get natural gas out of shale. So you can see here in this picture, we basically pump down, we have this injection well, high pressure fracking fluids, which are proprietary. It's mostly water, but there's other things in there as well. It causes these fractures in this shale, and then the natural gas comes out. So people are also very worried about pollution of groundwater due to hydraulic fracturing. Some people think it's completely safe. Some people don't want it anywhere near them. A lot of people make money because if they have natural gas below their property, a company will come to them and said, we want to put a fracking well on your property and we will pay you in order to do that. So it's a source of income for a lot of people where these shales exist. Mining from tar sands, this is in Canada, you have large sections of forest that have been cleared so that those underlying soils can be excavated in order to get the oil from those tar sands. So as you can manage, this was a forest. It is no longer a forest. Now it's this kind of polluted wasteland, basically. So it is has a lot of environmental problems. How do we use oil? 15 to 16% is non-energy products. So things like solvents, fertilizers, we use oil to make fertilizers and pesticides, and plastics. Plastics are created from a byproduct of oil. So everything in your life that is not a plant-based plastic, which is most of it, is an oil-based plastic, including polyester. If you have polyester shirt, that was at one point oil. And then 70% is converted to gasoline or diesel, which is used to fire internal combustion engines, cars and trucks and so forth. And then another 7% is converted to aviation fuel. and 7% converted to heating oil. Most people, it was more common where I'm from in the Northeast to have an oil, heating oil in your house. You'd have a big tank that was in the basement that people would come and fill, and that was how you heated your house. Um, and you can see here we have some pretty large shale reservoirs, particularly around Pennsylvania and West Virginia, that have kind of relatively recently been put into production. So lots of hydraulic fracturing happening there, some in California. There was a film, Gasland, a documentary that was all about the potential dangers of hydraulic fracturing, which was kind of a controversial documentary. For natural gas use as opposed to oil, I lost my animation here, but that's okay. 44% is used for industry, the production of plastics, fertilizers, synthetic fibers, firing of furnaces. 25% is direct household energy. So you might have a gas stove in your house. You might have a gas dryer. Your heat in your house might be gas powered. That is fairly common. I have all of that in my house. 31% and growing is for electricity generation. So natural gas fired power plants release fewer pollutants and do not produce the fly ash like coal fired power plants. So they do produce 50% less emissions, but they are still producing greenhouse gas emissions for sure. This growing electricity generation is from these kind of new discoveries of these natural gas deposits, and it is cheaper to get natural gas out from hydraulic fracturing than it is to do coal mining. So what are some of the environmental impacts of oil and natural gas? The first obvious environmental degradation from things like hydraulic fracturing and exploration. Then there's the drilling and transportation of oil and fear of oil spills. So here is the Deepwater Horizon, which leaked oil into the the Gulf of Mexico for quite some time. The Dakota Access Pipeline controversy was all about concerns about oil spills running through native lands, the potential for oil spills in native lands. So generally speaking, when we have an oil spill, it is very hard to clean up, especially if it is in the water. Especially if it is in the water. It stays there for an incredible amount of time. And it's also, when you have something deep underwater that's leaking, it's also just very hard to fix. So this oil well leaked oil for quite some time. When I was a kid, we had the Exxon Valdez, which was an oil tanker that kind of ran aground and leaked tons of oil and made world headlines. And then we also have concerns about emissions, carbon monoxide, carbon dioxide, hydrocarbon, nitrogen oxides, those greenhouse gas emissions. And then also political turmoil, right? Who has oil, both Gulf wars and on some level had to do something with oil. Generally speaking, we tend to get involved in places where that is a concern. Not that that was completely about that, but it was at least partially about that. And then also, controversies like the Arctic National Wildlife Refuge has significant oil reserves below it. But environmentalists fear that if you drill for the oil, you could have serious consequences for this very, very fragile ecosystem. And then also if something happens, it's a very remote area. So how do you get that fixed once that happens? And how do you mitigate for that? There are also people who live, in these areas, often Native Americans. The next one I'm going to talk about is nuclear power. And so where is that sourced and how do we produce it? So it uses heat that is generated by the fission of atoms. It basically uses the decay of uranium. Uranium is found in many locations. We have reserves for about 120 years. It produces currently about 16% of global electricity. It's a little higher than that in the United States. Um, but where is uranium? We have it in the United States. Australia has the most uranium. And again, um, mining is an environmentally destructive process. But when we uh, create nuclear power, we have heat that is generated by the fission of this uranium. And um, the problem is that these have to be constantly cooled. And so you have the fear of meltdowns and radiation leaks. And then you have these spent fuel rods, which I'll also talk about in a minute. Very close to my house, I live in San Clemente, San Onofre, which is no longer an active site, has plenty of spent fuel rods on site. And many people in my town want those spent fuel rods to be removed and taken someplace else because we're concerned it's very close to our community. So, what are some of the environmental impacts of this source of power? The benefits and costs are really disputed. There are some environmentalists that really believe that this is going to be a core component of our energy future, and that we really need that. But a lot of other people have said no. We have these kind of large open pit mines where we extract uranium. There's all of this thermal discharge that happens. And then there's the concerns about meltdowns and radiation leak, which is what happened here in Chernobyl in the 80s, where you had this leak. The government kind of lied to people about what was happening, but now you basically have an entire area that is a deserted wasteland because of the radiation leak. And then again, that spent fuel, which is a concern for me. It's very close to my house. And when Japan experienced an earthquake several years ago and a subsequent really devastating tsunami that killed thousands of people, they had one of their nuclear reactors started to melt down because the generators that keep that cool flooded due to the tsunami, and there was concerns that they were going to have a massive one, and it was contained fairly quickly. But we are in an earthquake zone, and we have spent fuel rods within a 15-minute drive of my house. But a lot of people do like it because it does not release greenhouse gases, right? So it is, there's no carbon that is being released. So a lot of people believe that this is a very important component. But so here are these spent fuel rods sit in these cooling towers. And the plan in the United States was to eventually have a containment area at Yucca Mountain for all of this spent fuel that was going to be very, very safe and away from people. But it's been really political and very controversial. Nevada doesn't really want it. And so all of these temporary storage containers have now basically become permanent storage containers. And then there's also the fear of transporting it. So if you transport these spent fuel rods, how do you transport it? How do you make sure that you don't have a radiation leak when you're traveling through residential areas? And then also people have very big concerns that these sites that are storing this radioactive waste could be targets for terrorist attacks that could then lead to radiation poisoning for large amounts of people. Next, I'm going to talk about renewable energy, which, ideally is the direction that we are moving into, hopefully. So renewable energy is primary energy sources that are continually replenished. So our current reliance on fossil fuels meets 80% of our energy needs, but we only have so many reserves. So whether or not climate change is an issue for you, we're eventually going to run out of these things. So we need to have some other energy sources in place. And so the way we get renewable energy is either from falling water, or from wind, or from sunlight, or from the Earth's heat. Think about geothermal energy, and ocean tides and waves, and then biomass. I just for time, because we're behind in the semester, I'm not going to talk about geothermal energy or ocean tides and waves. If you want to know more about that, go to your textbook and read about it, because it is very interesting. But um, all of these energy sources are really reliant on the sun. Like they are in some aspect solar energy, with the exception of that geothermal energy, just because wind is created by uneven heating. So, and plant matter is grown with sunlight. So you really need um, these kind of, it's really solar energy kind of at the end of the day. So, generally with renewable energy, right, we want to transition to renewable energy in the long run, not just for climate change, certainly for climate change, but also because we want to, we're going to run out of those non-renewable sources. So some general challenges with that conversion, why aren't we just converting to all renewables? Renewables, are intermittent, not so much as what some people talk about, that like if the sun's not out, you can't heat your home. That's not how it works. But some places have more access to solar energy or wind energy. Um, and then the technology to harvest it is there, but funding that technology, getting that infrastructure. So when you have non-renewables providing 84% of energy, you need to have infrastructure in place to transmit that energy to people. Benefits, far fewer environmental impacts, obviously. It is a potentially infinite energy source as well, right? It's not like those non-renewables, it's not going to run out. So again, when we talk about, how much renewables we're using, again, it's a small portion of the amount of energy we use globally. And the majority of that is hydropower or hydroelectric power. Biomass and biofuels, things like ethanol, and then we have solar heating, solar electricity, wind, and geothermal. And geothermal is a much smaller percent because geothermal is really only available where you have that as an option. So Iceland can produce tons of geothermal energy. So there are four general categories of challenges to renewable energy. First is the new technologies. Many are still in development or the early stage of development. There's also economies of scale. So the scale of that is still small. And what I mean by the economies of scale is if only a few people are purchasing these things, the cost is really high. As more and more people purchase them, they go down. So solar panels used to be incredibly expensive, and now having solar panels on your home is much more affordable than it used to be. And now you can get solar panels on your home and sell excess power back to the grid. Then there's also the externalized costs. So we heavily subsidize fossil fuels in this country. So the government keeps fossil fuels inexpensive. And so it's harder to switch if you are not getting subsidies for those renewables. And that also, you're not really getting the full idea of that pollution when these fossil fuels are being subsidized. And then there's also limited consumer knowledge and understanding. A lot of people thinking that renewables couldn't possibly provide us enough energy when in actuality it very much could. So when we look at that cost of solar panels, right? So the red line is the price of solar panels. So 1995, extraordinarily high, but then as more people start getting solar panels, that goes up, and then the price drops, right? Because now more and more people are getting it, and so people can produce it for cheaper. So how do we source and produce solar energy? So there's a couple different types. There is passive solar technology, which uses solar energy without mechanical devices. So basically, this is natural light and heating. Very simplistically, I wake up in the morning in my house, it is cold. the sun shines, it comes through the house and it warms my house up, and I don't have to turn the heat on. Lots of buildings are designed now to really take advantage of this natural lighting and heating. And we have a lot of really interesting windows being produced now that kind of allows that sunlight in when you want it and then darkens it when you don't. So you can really take advantage with no mechanization, just that natural lighting and heating. And then we have active solar, which this is what uses mechanical devices. So this is rooftop solar panels, the photovoltaic ones, and then you can also have solar water heaters. But here is, again, on this house, you have these solar panels, and then you have this cell, and it's capturing that energy into a battery. So, it stores that energy when the sun is at its peak. And then so, it's still there when it's dark outside. It's not that you can only use solar energy when the sun is out. And then we have systems for concentrating solar power, where we have reflectors that when you have these kind of solar farms, where you have all of these mirrors that turn in order to capture as much solar power as possible. And one of the great things about solar power is you do not need a ton of infrastructure for it on the very small scale. So here is, in the high Andes of Peru, you have a family in a very small dwelling that has a little solar panel that's able to, work some appliances and some lights. So sometimes you will see, even if you're driving around, you'll see a sign that requires some type of electricity, and there'll be a small solar panel on that sign. Some of the advantages of it, it's widely available, which is great. There are very few environmental costs. Some of the disadvantages of it, it can be intermittent. Depending upon the season or the time of year, you can capture more or less solar power. It's also regional. Obviously, the Southwest United States receives more direct solar radiation than Maine does. And then also distributing it, right? We need power lines in order to distribute this out. If you have a solar farm out in the desert, you are going to need to distribute it to homes. Next is biomass energy. And so how do we source and produce biomass energy? This is energy contained in wood and other plant matter. These are our pellets. It's basically derived from solar energy, right? We need photosynthesis in order to produce these. And so biomass can be burned to produce energy, such as wood and charcoal, and also crop residue is sometimes burned. And then ethanol is one of the big ones. We produce ethanol from corn. Part of our gas at the gas station, you can see it will say there's a certain percentage of ethanol in your gas that you are pumping into your car, and then other forms of these biodiesels. Some of the advantages, so your book says it's carbon neutral, and I put carbon neutral question mark. So the idea behind biomass energy being carbon neutral is basically that plant, as it grew, captured carbon from the atmosphere. And so when you burn it, you're just releasing that carbon back out. But there is a lot of cost in producing, there's a lot of carbon cost in producing that biofuel, because generally speaking, the way that we farm uses a lot of fossil fuels. So often you're using fossil fuels to grow these quote unquote carbon neutral fuels. They emit less nitrous oxide and sulfur dioxide than fossil fuels. They can be fairly evenly distributed. Some of the disadvantages, impacts on the food supply. So this can happen if you are growing corn and you can get a better price on your corn to make ethanol. It's potentially going to mess with the global cost of corn for food. And then we also have an inefficient choice of fuel crops, and then also land clearing. So when you have portions of the Amazon being cleared to grow palm oil, to make biofuels, that is not environmentally ideal. And again, this is what corn production looks like in the United States. We've put fossil fuel-based fertilizers on it. We have a lot of machinery in order to capture that. So there is a carbon component to that. And again, here is that deforestation to make plantations to create palm oil, which is an important source of biodiesel. But you've removed that store of carbon that was in that rainforest in order to do that. Next is wind power. And so how do we source and produce wind power? Wind power is driven by the sun. So wind in general, if you took a physical geography class, you would learn about this, is caused by uneven heating. That causes different air pressure, and then you get wind as that air is moving around. So you have these wind turbines, and much like that other turbines that I've talked about, basically you're capturing that kinetic energy from the wind turning those turbines. It's only currently 1% of global energy. It is the fastest growing renewable. Texas produces the most wind energy in the United States. You have lots of big open land. Lots of people who have ranches and other things like that can put up some wind turbines on their property and make some money off of that. So it's growing 24% per year. In the US, it accounts for about 3.5% of electricity production, and it's projected to double by 2020. So it really is growing. These wind turbines are massive. If you get close up to them, if you drive, east out to Palm Springs, or you try to go to Las Vegas or something, you can see them there out in the desert. And if you can get close to them, they really are very, very big. The advantages: no fuel, no pollution, obviously. Economically, it provides jobs, right? People need to produce these mechanisms. They need to service them. Also, it's a domestic fuel, so we're not worried about trying to import it from somewhere else. It is CO2 free. No CO2 emissions are happening because of that wind power. Some of the advantages, again, being intermittent. A lot of people are upset about the aesthetics. So when you have giant wind farms, a lot of people want to put them offshore, and some countries have put them offshore. There was a big fight in Massachusetts about offshore wind farms. A lot of people say, I don't like looking at that. You're pulling away from kind of my cultural landscape. And why that may it seem like necessarily the best issue, but like people are very attached to their landscapes. And especially when you're talking about Native Americans, like these are, these traditional cultural properties, they're called, like these are almost like religious sites. So imagine trying to put a wind turbine in your church. And then impacts on wildlife, particularly birds. Birds do get killed by these rotor blades. The last one I'm going to talk about is hydropower, which is from water. It is consistently supplied by the hydrologic cycle. Water is always moving around the planet, so we have that there. It's the most abundant renewable energy. 57% of renewable energy comes from hydropower. It is mainly used for electricity generation, and we do that in two ways. Impoundment is where we have a dam, we create a reservoir. So here you can see we have that river kind of back up behind here, and then we control how much water it goes through. It turns that turbine again, and then we capture that electricity that's produced and that kinetic energy, and then it's transmitted. And then we have run-of-the-river systems, where a portion of the river is diverted through a powerhouse, which is generally less environmentally destructive. So advantages of hydropower: it is fuel and pollution free, which is good. It is relatively inexpensive. And it also provides flood control and water storage. So we don't just create dams for hydroelectric power, we also create it to control flooding, and then also having drinking water behind those reservoirs. And it provides continuous electricity. So it doesn't have to be raining. As long as that river is moving, you're going to get that electricity. Some of the disadvantages of it include the loss of land. So here is the Three Gorges Dam in China, which is the largest dam in the world, I believe. Uh, and so when you create this reservoir, you flooded all of this land. And so people were living in this floodplain and they were removed in order to create this. So you have that loss of land that's now underwater, ecosystem disruption. So fish can no longer move through that system. Some have like these fish bypasses, which aren't um, necessarily as effective. Um, and then also kind of generally the flooding of that landscape and the destroying of it. And then you also have the initial cost. Building a dam is incredibly expensive. Generally speaking, in the United States, all major rivers have been dammed, at least at some point on the river. And actually now the trend is towards dam removal. So removing these older, smaller dams in order to kind of invest in making the larger ones more efficient and restoring those ecosystems. So that is the end of our lecture on energy.